Okay, so welcome. I forgot to give you your example to do on your own for center of mass. So before we get started, here's your example. And again, so these are on the number line. So we have this mass placed at this point on the number line. And respectively, this mass with this point on the number line, this point mass with this location on the number line, and so on. So I want you to use this information and find the center of mass. And again, just reach out to me if you have any questions. Just make sure you're able to do it. Other than that, that's about it. So now, let's move on. So now in this video, I want to talk about expanding this concept of center of mass from one dimension to two dimensions. So let's look at a plane. So let me draw. Okay, so we have our x-axis, we have our y-axis, and let's say we have x sub 1, y sub 1, and let's say we have this situation here. So let's say this is a point mass located at x1, y1. Okay? So we can generalize this to this case, because now in the one dimension we were talking about the origin, right? The origin, how far from 0, right, on the number line. And so in this case, we were talking about how far the x values, the point masses, were from the origin. Well, in this case here, now we're going to add another dimension to it. We're adding the y direction. So now we're not putting point masses on the number line on the x-axis where y would always be 0, right? Now y is going to be something other than 0. So I'm kind of building this up for you. But now, so now we have two directions. We have the x direction and the y direction to contend with, okay? So how do we do that? Well, we're going to split this up into two vectors, if you will. We're going to have a distance from the x-axis, and we're going to talk about a distance from the y-axis. So instead of talking about how far the x value is from the origin, now we're going to say, hey, how far is this point from the y-axis, and how far is this point from the x-axis? And so what we're going to do is we're going to define our moments. Now we're going to be dealing with more than one moment. We're going to be dealing with two moments. One moment with respect to the y-axis, the other moment with respect to the x-axis. And so that means we're going to have to define this way and this way. So let's define m sub x and m sub y. Okay, now, in this case here, well, with respect to the x-axis, means that I'm going to figure out what my distances are from the x-axis. Okay? Which means it's going to be in terms of y, right? If I'm doing my moment with respect to the x-axis, that means that's my reference point, right? That means I'm going to figure out my distance with the x-axis as my reference point. Well, how do I do that? Well, I use the y-coordinate, right? The y-coordinate tells me how far I am from the x-axis. So in this case here, my m sub x is going to be m1 times what? It's going to be y1. Okay? So let's say, again, let me fill this in. So let's say this is a point mass of M1. Okay? So now what about My? This is the moment of the system with respect to the y-axis. So that means I'm going to be looking at x, the x-coordinate, right? How far am I from the y-axis? That's going to be the x-coordinate. So this moment is going to be defined by M1, x1. Okay? So that's why this is x, and this is y, and this is y, and this is x. You got to understand the terminology, right? This is with respect to x, the x-axis, which means I'm going to use the y-coordinate because the y-coordinate is what tells me how far I am, right? And also, similarly, this moment with respect to the y-axis means I'm going to have to focus on the x-coordinate because that tells me how far I am from the y-axis. Okay, so again, just get that straight. Okay, so now in the next video, I'm going to put this together. We're going to introduce another theorem of now how do I calculate these moments and how do I find the center of mass when I have a point in a plane instead of on a number line. See you next time.